Hi guys, welcome back to AP Environmental Science. In today's video, we're going to be covering topics 3.1 and 3.2, which is terrestrial and aquatic biomes. So make sure as you're watching, you fill along the corresponding section in your note packet. Okay, so this should be a review from bio and chemistry, but this is just a review of life on Earth and the biosphere, which you should have covered in your ecology unit when you took biology. So, what is the biosphere? It's all parts of life on Earth where life exists. It's land, water, and the atmosphere. It extends from 8 kilometers above Earth's surface to about 11 kilometers below the ocean surface. So, it's all life on Earth where life exists. Here's a few important reminders. This is stuff that we went over a little bit in Unit 2. Weather is the day-to-day conditions of the Earth's atmosphere at a particular time and place. Climate is the average year-to-year conditions of temperature and precipitation in a particular region. So we should know that this is caused by trapped heat, which is coming from the solar insolation from the sun. It's going to be hotter at the equator because the Earth is tilted on an axis and the sun's rays are hitting the Earth directly on Earth's axis at the equator, whereas the poles tend to be colder because they're tilted away from Earth's axis. Now, throughout the world, there are at least 10 different biomes. Each of these biomes is defined by a unique set of abiotic factors, which are the non-living factors, particularly climate. So that's going to be the average year-to-year temperature and precipitation that happens in that area. And each of these biomes have their own set of living things that live there, depending on what adaptations they have that allow them to live in that biome. So what we're going to do today is I'm going to give you guys a really brief overview of the world's different biomes, and we are then going to move into the aquatic biomes. These are just the terrestrial ones for right now. Then we'll move into the aquatic ones, and each of you should be familiar with at least one of these biomes, depending on what biome you received for your biome research project. So I hope you're at least familiar with one of these. So let's get started. So as we look at this map, as we move higher in latitude, it tends to be colder and milder in terms of the climate. So it's going to be a lot colder and drier, whereas as you're somewhat in the middle latitude, it's going to be more temperate. It just depends again on where you are and how much of the sun's rays that you are receiving and what's happening in the oceans as well. Because if you look here at America, here we are. We are a temperate seasonal forest. But if you look over here, they're actually more of a temperate seasonal forest up north in the northern parts of Europe, but primarily a woodland, shrubland in places that are pretty much equal in terms of latitude. So it's not just latitudinally that determines your biome and your climate. It's also having to do with wind patterns and ocean currents and that kind of stuff, which is why the same thing over here on this side, we're also pretty equally latitudinally with the West Coast, but it's a different type of biome there. So this is a climatogram or a climatograph. You had to put this on your biome dating profile. So what this is, it shows you the average temperature and precipitation of each month of the year. So it's a double y-axis with temperature on one side and precipitation on the other, with the months of the year at the bottom. So this is showing you the average temperature and precipitation of the biomes. Some of them may look very similar, but you have to look at the values of the X and Y axis, particularly the double Ys, because they might look similar, but if you look at the values, okay, our highest value here is 100. with the highest average temperature being in July, hovering right below 80. So this might look similar to maybe a tundra, but a tundra y-axis for the temperature is going to be a lot lower. So you really have to look at the x and the y, just the double y-axis to really see what biome it is, because they might look similar, but the values will be different. So as we move up laterally, it's going to be a lot colder and drier. And as we're closer to the equator, it's going to be hotter and wetter. So let's start off with the very northernmost part, which extends into different parts of the globe, which is the tundra. It's a cold and treeless biome with low-growing vegetation defined by a permafrost. A permafrost is a frozen layer of soil that prevents drainage and also prevents any heavily rooted trees from being able to grow there, which is why it's treeless. The soil and the ground is frozen solid, and as you get deeper, it only gets colder in this soil. So you're not going to have any trees, very little plant life. During the summer months, it could be a little bit warmer and you'll have some semi-annual growing plants, but pretty much you're not going to have any big trees here in the tundra because of that permafrost, because it's so cold in these parts. A taiga is a forest biome made up primarily of coniferous evergreen trees. So these would be like Christmas trees. They're the ones that don't lose their leaves during the winter. They can tolerate the colder seasons, and they have very short growing seasons. And sometimes it's referred to as the boreal forest. And they're found primarily, again, in northern latitudes. If we go back really here quickly to look at the tundra, you'll notice that we have some in the southern hemisphere and not really up in northern latitudes. That's because these are primarily in mountain ranges. And as you go up a mountain and you're rising above sea level, it gets colder the further you are up in the atmosphere. So we should know that from Unit 2, that the Earth, the bottom layer of the troposphere where we live, is a lot warmer because it's heated by the sun, and also it's heated by the Earth. And as you move up towards space, it gets colder. Here's the temperate rainforest. It's a coastal biome typified by modern temperatures and high precipitation. So if you guys have ever seen Twilight, that is this biome. It's the cold and rainy and really wet. It rains a lot in these temperate rainforests. That's why they're called a rainforest. It's not a tropical rainforest because it's not hot. Instead, it's a temperate rainforest because it's cold. It does have pretty warm summers, but it does have really cold and snowy winters. A temperate seasonal forest, however, is what we live in. It's a biome with warm summers and colder winters with over 39 inches of annual precipitation. So this is the biome that we live in. We have all the changing of the seasons. Very, very, very beautiful here. And it's also in other parts of Europe and Japan and parts of China and Asia. A shrubland is a woodland characterized by hot, dry summers and mild, rainy winters. This is primarily found on the west coast of the United States, as well as in parts of the Mediterranean, South America, South Africa, and Australia. A temperate grassland. This is what makes up the entire Midwest. So it's referred to as a cold desert. It has cold, harsh winters and really hot, dry summers. Tropical rainforest. These are the most biodiverse places on Earth. They are very warm and wet with very little seasonal temperature variation. They're pretty much the same year round, whether it's winter or summer. It's going to be hot and wet here all of the time. Savanna is a tropical seasonal forest. It's known for its warm temperatures and distinct wet and dry seasons. This primarily makes up Africa. Now we have the hot desert biomes. They're located roughly between 30 north and 30 degrees south. It's very hot during the day, but very cold at night. It's primarily made up of sand, and it's very dry here. It rarely rains. So, as the Earth is experiencing global climate change, biomes can shift in location on Earth, and we're seeing this now with the melting of the ice caps. It's getting warmer in the tundra regions, meaning that parts of the boreal forest can shift upwards. So, um, the warming climate will shift, just like I said, the boreal forest upwards as tundra permafrost soil melts, and lower latitudes become too warm. So that is topic 3.1. Now let's move into the aquatic biomes. So the majority of water on our planet is salt water. 97% of our water on Earth is salt water found in the oceans. The remaining water is fresh water. Now, of that 2.78% that is fresh water, 77% of it is trapped in ice and glaciers that's unusable to humans. The other 22% is found in the ground. So that's groundwater that we're going to be using for our everyday activities like drinking, cooking, cleaning, showering. This is where we get the majority of our fresh, usable water. The other 0.47% is lakes, rivers, and streams. And the very small amount would be water vapor in the atmosphere. So here's just an overview of the aquatic biomes around the world. There are not as many as the terrestrial ones, but there are quite a few, and they're defined by either saltwater versus freshwater. So these aquatic biomes are going to depend on salinity, which is the saltiness, the depth, which is how deep they are, because the sunlight penetration is going to, make more or less photosynthetic organisms live there, depending on how deep or shallow the water is. The flow determines which plants and organisms can survive and how much oxygen can dissolve into water. And the temperature, of course, is a big one too. Water too cold cannot have life in it. So now we have the freshwater biomes and the marine biomes. So the freshwater biomes are going to be rivers, lakes, and groundwater, whereas marine biomes are going to be the coral reefs, the open ocean, estuaries, and intertidal zones. So the marine estuaries are some of the most important places on Earth because they are one of the most productive biomes in the world. It's an area where freshwater and coastal water mix together. So it's like, we call it brackish water. It's a mix of fresh and salt. And later this year, we will be going to the estuaries of New Jersey up in Sandy Hook for our class trip. So this is an incredibly important part of the life cycle of a lot of fish and shellfish because they will come up here and lay their eggs. And we should know, like a little common sense, that if your young are killed early on, your population is going to have a massive decrease. And unfortunately, our marine estuaries are some of the most vulnerable places because of construction, pollution, and we'll learn more a little bit about that later this year. But our marine estuaries are where our fish and our shellfish are coming to lay their eggs and have their babies. And they're currently being destroyed due to human activity. Now we have coral reefs, another incredibly endangered biome due to ocean warming and ocean acidification. Again, we'll learn about this later this year. But they're found in shallow waters by the shoreline. They represent the most diverse ecosystem. Corals are colonial organisms that secrete a limestone skeleton, and algae live inside them. Algae live inside of them for structure and the CO2 released by the coral. We're going to learn a little bit more about coral bleaching later this year. The open ocean is one of the least productive biomes. It just depends on where you are in terms of depth, and it's classified into two main parts. The photic zone is the upper layer with enough light to support photosynthesis, and the aphotic zone is the lower layer where sunlight does not penetrate. So photic means light or, sunlight. Aphotic literally means without life, or without sunlight. Whenever you see the prefix A in front of a word, it means without. Productivity in the ocean is related to the influx of nutrients in a given area. So remember, we talked about upwelling in our last unit, which is when the cold, deep, nutrient-rich water mixes with the warm surface water and it brings up all of these nutrients for the plankton, the photosynthetic organisms to to live and have nutrients. And this is incredibly important because phytoplankton are at the bottom of the food chain, so they provide food for our primary consumers. Intertidal zones are the narrow band of coastline that exists between high and low tide. This biome creates great biological challenges for the organisms that live there because they have to be able to withstand changes in the tides. So tides go in and out depending on the moon. When it's high tide, you have a lot of water and the water is deep along the shoreline. When it's low tide, the water is all the way out into the sea. So the organisms that live there have a very wide range of ecological tolerance because they can withstand this different changing that happens daily. And the same thing, as always, humans are impacting these ecosystems as well. Now let's move on to freshwater biomes, again, only making up less than 3% of our freshwater on Earth. Less than 3% of our water on Earth is the fresh water. So fresh water on Earth is found in rivers, streams, lakes, ponds, and underground reservoirs. The majority of fresh water is going to be found in the ground. Most of it is trapped in ice. So flowing fresh water that originates from precipitation, melting snow, or underground springs is going to be found in streams and rivers. Streams are smaller, they have less water in them, where rivers are larger, they're rapidly flowing, and they have more water. Lakes and ponds are water that's standing, meaning it's not flowing. Some parts are too deep to support plants. For the same reason in the ocean, it's aphotic, meaning that not enough sunlight is going to be reaching there. And lakes are separated into 3 different sections or zones. The littoral zone is the shallow area of soil near the shore. You tend to have a lot of plants anchored in the soil here because there's enough sunlight getting through to support photosynthesis. The limnetic zone is open water and it's too deep for rooted plants. And the profundal zone is very deep and no light reaches this area. Oh, and that's it. Okay. So next video, we're going to talk about the nutrient cycles that are going to occur within the biosphere. So this is not due until after we get back from the break. If you have any questions, let me know. I'll see you guys soon. Bye.